Okay, lesson 2.4a, horizontal projectiles. When we talk about a horizontal projectile, what we're talking about is an object that is thrown horizontally, so neither up nor down, and it's going to fall. My writing's not very neat, but we're kind of going with it. And so what we're looking at here is that there is a trajectory, which is the parabolic motion of a projectile. Now, what we're seeing is actually half of a parabola and not a whole parabola. It's kind of coming down. We're not seeing the up part. It starts horizontal and goes down, starting from the top. The range is simply the horizontal displacement covered by the projectile. Displacement covered by the projectile. So if we take a look at, let's say, this one, this distance here, from this point onwards, that is your range, or your horizontal displacement. There's a couple of things happening. We've got two different things happening in the x and the y direction. In the y direction, the up and down direction, we have things that are falling, which means we have an acceleration due to gravity. Now, the other thing that we can have here is that it's falling some height, and that height is the displacement in the y direction, which sometimes is just used as h, or a height that is representative of that. Now, one other thing specifically with horizontal projectiles is that the initial velocity in the y direction is 0. This is 0 because there is no up or down at the beginning. In the x direction, we have some sort of velocity, and that is the velocity that it is thrown with. Because it's thrown horizontally, all the velocity is that initial velocity in the y direction, but there is no acceleration here. Because gravity works in an up-down fashion, not in an x direction. I like to think of it as, if you remember the Etch-a-Sketches, there were those things that kind of came like this with the little screens. This button controlled what's happening here with the x. This button here controlled the y. Now, this button, the x button, it's using in uniform motion. It is not speeding up. Where in the y direction, we are seeing a speeding up of the turning of that knob as it moves in that projectile motion. So the displacement in the x direction is going to be equal to the range. Now, one thing, and one thing only, is the same for both. Both these things are happening at the same time. So the time is same for both x and y. It's probably a little bit easier to see this when we actually do an example. So we'll do an example here. And our first example, we've got an object thrown horizontally with a velocity of 10 meters per second from the top of a 50-meter building, and we want to calculate the range. So it's a 50-meter building. It's thrown at 10 meters per second. And so what we're looking at here is we want to find out what this range is. Now, in order to solve this, I like to set this up as a t-chart. We know things in the x direction, we know things in the y direction. In the x direction, we know the velocity is 10 meters per second. We want to find that distance, which means we need to know the time in order to find the distance. There's no acceleration here, so we'll be using v is equal to dt, or specifically d is equal to v times t. Okay, so we'll need to find the time. We're going to find the time in that y direction. We know that the initial velocity is equal to 0 meters per second in the y direction. It's got a displacement of negative 50 meters per second, or sorry, meters, not meters per second, just meters. And it's got an acceleration of negative 9.81 meters per second squared, because as always, we assume that we're near the surface of the Earth unless we're told otherwise. Okay, and from this you are going to be finding the time. So the formula we're using here is d is equal to VIT plus 1/2 AT squared. VI is equal to 0, so we can eliminate that. Negative 9.81 t squared. Solving for t, you're going to multiply both sides by 10. Oh wait, I got 10 there. That's really 50. My mistake. 50 meters, so therefore 100 meters. Dividing that by 9.81 and then square rooting will get you a time of 3.19 seconds. Now, because this is happening at the same time, that means this time is also 3.91 seconds. So d being v times t, 10 meters per second, multiplied by 3.19 seconds, gets you a displacement of 31.9 meters, or 32 meters to 2 significant digits. Right, we've separated what's happening in the x and y. Y has acceleration because it's falling. X does not have acceleration. Therefore, the only thing that links the two, the only variable really that's passing between the two, is the time, because both what's happening in the x and what's happening in the y are happening at the same time. Let's take a look at a second example. In this case, we've got an object thrown horizontally from a cliff with a velocity of 18 meters per second, hits the ground 75 meters from the base, and we want to know how high is the cliff. So if we draw the scenario, we want to know what is this displacement. We know that this is 75.0 meters, and we know that this is 18.0 meters per second. Separating the x and the y, we know that we've got this as being 18.0 meters per second. We know the displacement is 75.0 meters. We know the initial velocity is equal to 0 in the y direction because it's a horizontal projectile. And we know the acceleration is equal to negative 9.81 meters per second squared. In order to find the height, this displacement, we're going to need to find something else, but we know that the one thing that crosses over is time. So v is equal to d over t, or t is equal to d over v. So that time is equal to 75.0 divided by 18.0. And so we wind up with a time of 4.16 seconds. Right, it's actually 4.166 repeating. That can be used here, where we use d is equal to vi t plus 1/2 at squared. We're looking for that displacement. VIT can cancel out, so we've got 1/2 negative 9.81 4.16 all squared. And as you solve for that, you wind up with an answer of negative 85.2 meters to 3 digits. Now that negative is just saying that it's fallen 85.2 meters, right? It's indicating the direction. It fell downwards. It didn't fall upwards. So the scalar quantity would just be the height of 85.2 meters. Okay, I would like you to give this one a try. 10-meter high building lands 7.2 meters away from the base, and we want to know how fast this object was thrown. Pause the video, give it a try, see how you do. If you have difficulties, please raise your hand or ask a question. Okay, so if you tried this, you got the 10-meter high building. It's landing 7.2 meters away from the base. So 7.2 meters, the displacement of 10. And you should have found that you had a time of approximately 1.4 seconds. That is a thing that comes there, and v being v is equal to d over t means that we've got a velocity of 5 meters per second. Notice we are just asked how fast, so we're not really worried about the arrows, not direction, it's just throwing. We don't know if that's east, west, northeast, etc. Okay, if you do have any questions, please let me know, and thanks for watching.